We are now going to learn about graphing absolute value functions. Now, this is different from other lines that we may have graphed already. So we'll start with a review. I want to graph a linear equation first, and I'm going to write it in function notation. So we're going to graph f of x is equal to 2/3, nope, not 2/3, 2x minus 5. F of x equals 2x minus 5. Now we may notice right away that that is in slope-intercept form. We can use the 2 and then minus 5, the slope and the y-intercept to graph that line. But I want to do it a little bit differently. I want to remind you of how we also used at one point tables of solutions to find points on our line, because that's what I want to do, at least to start introducing this topic. So I'm going to choose several values of x, numbers that would be along our x-axis. I use a negative number like a -4, and then a 0, and a 2, and a 5. I'm going to use those 5 numbers. I'm going to evaluate this function. So I'm going to take f of -4, and that's going to be 2 times -4 minus 5. Calculate that. 2 times -4 is -8. -8 minus 5 is -13. And of course, I picked something that doesn't fit on the graph. Let's do 0. F of 0 is equal to 2 times 0 minus 5, which is 0 minus 5, which is -5. F of 2 is equal to 2 times 2 minus 5. 4 minus 5 is -1. And f of 5 is equal to 2 times 5 minus 5, which is 10 minus 5, which is 5. We would then go through and plot these 4 points. The first one, as I mentioned, I realized right away, 413 doesn't fit on our graph. -413 would be down here somewhere. So we'll start with 0, -5, which is here. Then 2, -1, which is here. And 5, 5, which is right there. And then I'm very bad at drawing straight lines on this tool, but I'll do my best. I have to go nice and slowly. We would draw a nice line through those points. You will notice that this does have a y-intercept of -5, which is here, and it does have a slope of 2. Remember, we can write that as 2/1. So from this point, we go up 2 and over 1, up 2, over 1, up 2, over 1, and we keep landing back on the line. So that's another way that we could have graphed this line. But I just wanted to remind you of this. Okay, so that's a review of graphing linear functions. Now we're going to move on to graphing absolute value functions. So let's start with the most basic of absolute value functions. Graph f of x is equal to the absolute value of x. Now, what I would challenge you to do is pause this and see if you can figure out what this might look like. I'm going to keep going. So we have x, and we're going to make our table. I want to make our table again. I should technically, instead of making a y, I really should have made this f of x. But it's okay. Okay, so we're going to pick some numbers just like we did in the last one. So I'm going to pick some numbers for x here. Let me start off with some nice easy ones like 0, 1, and 2. So f of 0 is equal to the absolute value of 0. And what's the absolute value of 0? Just 0. How about f of 1? Well, that's the absolute value of 1, which is 1. And absolute value of 2, f of 2, that's equal to 2. So we have really the same numbers so far. So if I start plotting these points, I have 0, 0, 1, 1, and 2, 2. These 3 points, 0, 0, 1, 1, 2, 2. So you might initially think, oh, this is just this line that goes, that's really awful. I told you I was bad at it. right through here. You might be thinking that, but wait, before we jump too far ahead, it's always good to pick some negative numbers too. So let's pick -1 for x. F of -1 is the absolute value of -1. And what is that? We know that is +1, +1. So if x is -1, then f of x is +1, or the y value is +1. Well, where's that point? -1, +1 is right here. If we do -2, f of -2 is equal to the absolute value of -2, which is, that's right, +2. Well, where's that point going to go? -2, +2. Look what we have here. We have this V shape, okay? We could keep going. If we went in the positive direction, we're going to be at 7, 7. If we go in the negative direction, -7, 7. The y value is always going to be the positive version of the x value. And so our line looks like this. It's a V shape that goes in both directions. And that is what the graph of an absolute value function looks like. It always looks like a V. Now, there are variations to that. So let's look at a couple other variations. Let's graph. I'm going to make this one just y, because sometimes you will see them written as y equals. Y is equal to -3 times the absolute value of x. So pause the video and see if you can graph this on your own. I'm going to keep going. So maybe you graphed it on your own, or maybe you even just made a prediction, right? Make a prediction on what you think might happen when you put this number out front of our absolute value. So let's pick some numbers here. I'm going to do 0, 1, and 2, just like before. And then I'm going to do -1 and -2. So y equals -3 times the absolute value of 0. Calculate your absolute value first and then multiply. This one is going to be 0. So again, we have the point 0, 0. The next one is 1. Y is equal to -3 times the absolute value of 1. Well, that's going to be a +1. So this is going to be a -3. Where's the point? 1, -3, 1, -3. So this is going in a different direction than the previous one. How about 2? Y equals -3 times the absolute value of 2. The absolute value of 2 is 2, times -3 is -6. If we do it with these two numbers, oops, I forgot to graph that one, 2, -6. Let's see what happens. -3 times the absolute value of -1. That's going to be the same thing as this one, because the absolute value of -1 is a +1. 1 times -3 is -3. So we get this same y value, but just on the other side of the y-axis. And then if we do the -2, the absolute value of -2 is 2, times -3 is -6 again. And we get this point over here. So what you'll see is we have the V shape, but now it is upside down. Why do you think it's upside down? Yeah, the negative made it upside down. And then it's also narrower. We have this 3 out front that makes it a little bit steeper, right? So our V gets a little narrower. So these absolute value functions are always going to graph a V shape, but they can also be going up, they can be going down, and they can also be wide, or they can be narrow.